In today's programme, we're investigating fire, looking at burning, transforming sand, making a volcano, and we're out to lunch, all on Science Tube.
This is the story of a special fire. Fire represents different things in different cultures. Dessehra is one of the Hindu festivals which uses fire. Burning the 10-headed king Ravan is the high point of Dessehra. The body is made of wood, a fuel. To burn, oxygen from the air needs to get to the wood, but it will. The structure is spread out. Each of these fireworks contains gunpowder, a chemical mix that burns really well. Finally, the organisers place kindling wood at the bottom of King Ravan to help it start to burn. The crisscross shape allows oxygen to pass through the wood. The crowds gather, awaiting the battle. Legend has it that the god King Rama killed the 10-headed King Ravan, who had kidnapped his wife Sita. Joined by his brother Lakshman and an army of monkeys, they fought a colossal battle and killed Ravan by shooting an arrow into his heart. The big moments arrived. The fire needs a source of heat to start, and here it is. Fireworks have their own oxygen within the gunpowder, which is a fuel. They can burn at an explosive speed. The wooden fuel combines with the oxygen in the air, a chemical reaction, changing the wood forever. There's not much left over. The metal screws haven't burnt. But with the wood, there's been an irreversible chemical change. The wood and King Ravan will never be the same again.
When a candle burns, there are lots of scientific changes. The candle wax is a fuel for the flame. The flame melts the wax around it. And the liquid wax goes up the wick, where it burns. The wax fuel gets used up. There's a chemical change which gives out heat and light. All that's left of the birthday candles is a bit of ash. Matt's got a strip of metal called magnesium. When it burns, there's a chemical reaction giving off a very bright light. The magnesium's combining with the oxygen in the air to burn. All that's left is a white powder.
Transparent, delicate and beautiful. It was once considered as precious as gold. Today, we use glass all the time. But this magic material actually starts off its life as sand. So how do you get from sand to glass? Sand gets mixed together with other powders like lead oxide and limestone. Lead oxide gives off a poisonous dust, so that's why Len is wearing a mask. There's also some broken recycled glass to help along a chemical change that will happen in the mixture. It'll only happen if you get it very, very hot. They're putting it into a hot furnace. It will heat the mixture overnight to around 1,700 degrees. By morning, the magic has happened. The extreme heats caused an irreversible chemical change. What's been made looks nothing like the ingredients. The mixture has now become liquid molten glass and is very hot. But Wally needs to work fast before the liquid glass cools down. To make a shape, he blows down the hollow pipe, like blowing up a balloon. He's shaping the liquid to make a bowl. He's blowing a jet of cold air onto the glass to cool it. As it cools, the glass changes from liquid to solid. But this bowl needs a base. Because this bit is still liquid and very hot, it is easy to stick it to the bowl. The glass is made by a change that can't be reversed. Heating it up again now won't make it back into sand, it'll just soften it. It will always be glass now. You can see how quickly the change to liquid reverses when it cools down. It keeps going from liquid to solid, a reversible change. Now it looks like a bowl. Next day, it's rock hard. And a pattern can only be cut into it using the hardest diamond saw. Difficult to believe that a few hours ago, this was a few thousand grains of sand, then a liquid. Magic sand, making glass.
Let's join Matt in the lab where he's got two clear, colourless liquids. But look what happens when he pours the two together. There's a chemical reaction. Not all chemical reactions need heat. Just mixing up these two chemicals has caused an irreversible chemical change. It's made something that looks totally different. And there's no going back to the colourless chemicals. Want to make a mini volcano? From the kitchen, get some sodium bicarbonate, sometimes called baking powder. Next, add normal washing up liquid. Then, a drop of vinegar. A chemical reaction is happening, making some new things, including a gas, carbon dioxide, which has made the bubbles. There's no heat involved, and you can't go back.
Deep in the heart of Chinatown, there's a whole lot of stuff changing. So what have we got on the menu? What Sam and Mars don't realise is that they're ordering a lot of chemical changes in the kitchen. There's heating, roasting and frying, all chemical changes. Lamb's our chef, making something from small see-through discs. Lamb is using a gas flame to heat his wok. The oil in the wok has to be at exactly the right temperature for this chemical change. Like many chemical changes, the end product doesn't look like the ingredients, and there's no going back. It can't be reversed. Prawn crackers. Next up, Lamb wraps raw prawns into the pastry. These are called wontons. As they fry, there's a chemical change. The pastry and the prawn look and taste different from when they were raw. They're chemically different. Now, onto the main course. Rice and a Chinese speciality, egg fried rice, is on the menu. When you cook an egg, it's changed forever. A chemical change. This is white, rubbery tofu whilst it's raw. But a couple of minutes in Lamb's wok, and it's changed forever. Time in the hot oil, and there's a reaction, another chemical change. So most cooking is just that. An irreversible chemical change. So, the science of cooking has helped our happy diners. Without it, the meal would be pretty hard to digest.